Earth-like planets and why scientists are eager to study them. Does life exist beyond Earth? Can life exist beyond Earth? Well, finding a planet similar to ours is one of the main goals of today's astronomers. And with the discovery of nearly 5,000 exoplanets since 1995, scientists have been trying to investigate if any of them have Earth-like qualities that could potentially sustain life. In today's video, we're going to be talking about Earth-like planets and why it's so important to study them. But before we begin, make sure to subscribe to Sky's TLYT and hit the bell icon for notifications. Now let's get into the video. Earth is an extremely unique planet. Coming into existence under cosmically perfect conditions, it's been able to manifest and support life for close to 4 billion years. How is it that our planet's been so successful in sustaining complex life while other planets just seem so empty? Well, as far as we can comprehend, Earth's life forms came to be thanks to probably the most important chemical to ever exist: water. Water is life, literally. If we don't have water, life as we know it wouldn't exist. Scientists have been scouring the universe for ages, searching for signs of water because they understand that where there is water, there is life. In the search for life outside our solar system into the greater universe, scientists have created very specific criteria for planets that can potentially host complex life. Firstly, a planet has to be relatively small. Smaller planets potentially have rocky surfaces, which is important because we need terrain to stand on. Secondly, it must orbit within its host solar system's habitable zone. The habitable zone is a solar system sweet spot, and it's extremely important because when a planet exists there, water has the potential to exist in liquid form, the most crucial key in hosting complex life. Other factors taken into consideration include a planet's atmospheric composition and the condition of its host star. Over the years, scientists have developed several distinct techniques in order to detect and observe these faraway planets, and the technique that's helped discover over 3,700 exoplanets is known as the transit method. It's very simple. When a planet passes directly between its star and the observer, the planet will dim the star, similar to solar and lunar eclipses on Earth. When a potential solar system is detected, astronomers measure the light of its star through a system called the light curve. When a planet transits over its star, the light curve fluctuates, and the bigger the planet, the deeper the light curve will be. The second most common technique used to discover exoplanets is the radial velocity method. Orbiting planets will often cause their star to wobble depending on their size. In our solar system, Earth can only make the Sun wobble a little bit, but bigger planets like Jupiter will have a much stronger effect. How scientists detect the wobble in a star is through its Doppler shift. In space, the farther an object is from Earth, the more its light will shift into a reddish color. So astronomers detect the wobble of a star based on the color of light it gives off. The bigger the planet, the larger the change in its star's color. A less common tactic to detect exoplanets is through direct imaging. Only about 55 exoplanets have been successfully discovered this way, because taking pictures of a planet is quite challenging. Planets are millions of times dimmer than the stars they orbit, so it's really difficult to take a direct image of them in the same way you take a picture of a planet in our own solar system. One device that supports this method is called a coronagraph, which uses a special device inside a telescope to block light from a star before it reaches the telescope's detector. Telescopes like the James Webb will innovate current direct imaging techniques, hopefully helping us discover more exoplanets in the future. Now that we've gotten to know some of the criteria and methods used to discover Earth-like planets, let's dive into those that have shown the most potential to support life. Kepler 438b. 640 light-years away from Earth is Kepler 438b, categorized as a super-Earth. It was discovered in 2015 by the Kepler telescope, a space telescope launched by NASA Kepler in 2009 to discover Earth-like planets orbiting other stars. This telescope has helped spot hundreds of exoplanets, with a good few of them falling within the habitable zone of their respective solar systems. Although Kepler 438b is categorized as a super-Earth, it's only about 1.5 times Earth's size, and it's theorized that it has a Mars-like surface, but its rockiness hasn't been confirmed yet. This planet completes its orbital period in about 35 days. Proxima Centauri b. Residing within the Centaurus constellation, Proxima Centauri b was discovered in August of 2016 through the radial velocity method. Orbiting around the red dwarf star Proxima Centauri, this planet is the closest known exoplanet to Earth, at just 4.2 light-years away. It orbits its star in just 11 days and is only about 1.27 times the size of Earth. The planet's rockiness is unconfirmed, but it definitely exists within the habitable zone of its solar system. Although it has the potential to be a promising planet, it's also possible that its surface is affected by high radiation due to the solar flares of its star. Kepler 442b. Twice the size of Earth, Kepler 442b was discovered in January of 2015 and is considered to be one of the more promising candidates in hosting life beyond Earth. The planet's host star is at least 40% less massive than our Sun, leading experts to estimate that the star can continue to live for up to 30 billion years. Kepler 442b was discovered through the transit method and sits 1,120 light-years away from Earth. As space telescopes advance the way we see the greater universe, astronomers hope to discover more about planets such as Kepler 442b and, more importantly, check if there are any traces of water on these planets. TRAPPIST-1d. Discovered in May of 2016 through the transit method, TRAPPIST-1d is approximately 39 light-years away from Earth in a rather unique place in the universe. The TRAPPIST-1 solar system contains several small Earth-sized rocky planets residing within its habitable zone, and TRAPPIST-1d is just one of them. This planet is theorized to be covered in water, potentially having a thin layer of ice, and with an orbital period of just 4 days, it speeds around its host star, completing an entire revolution in just under 97 hours. Glaser 667cc. Discovered in 2012 through the radial velocity method, Glaser 667cc is one of the first potentially habitable planets ever discovered. It's 22 light-years away and approximately 4 times the size of Earth, and it orbits its host star in 28 days. Its star is a red dwarf, thought to be significantly cooler than the Sun. Because of this, Glaser 667cc was thought to have resided in the habitable zone of its solar system, but upon further observation, there's a possibility that it's a little too close for comfort, possibly being baked by radiation and solar flares. Kepler 452b. Yet another planet discovered with the help of the Kepler telescope. Kepler 452b is believed to be about 6 billion years old, significantly older than Earth. Discovered in 2015 with the transit method, it's the first planet discovered that appears to be orbiting a star about the same size and temperature as our Sun. It has an orbital period of 385 days and a star that's about 20% more luminous than our Sun. Confirmed to be in the habitable zone of its solar system, it's still unknown if this planet has any pools of water that could potentially point to any form of life. In fact, pools of water haven't been confirmed on any surface in the universe except Earth, but we're still continuing our seemingly never-ending search for life out in the greater universe. Who knows if we'll ever come in contact with even the simplest form of life beyond our solar system. The best we can do now is to simply keep observing, learning, and searching, and maybe someday we'll finally come across an intelligent intergalactic civilization, or even just simple bacteria on another planet. Do you think we'll ever find intelligent life outside Earth? Let us know down in the comment section, and if you enjoyed the video, please hit the like button. Don't forget to subscribe to Sky's TLYT if you haven't already, and hit the bell icon to be notified whenever we post new content. That's about it for this video, so thanks for watching, and we'll see you in the next one.